Okay, so I know some of you are struggling with this reaction stoichiometry, and so I wanted to make one more video to give you a hand. And I'm going to scroll all the way back and start from the very beginning in chapter, sorry, I guess I would say in the first quarter. Okay, so like I was saying, I'm going to kind of go all the way back to it's probably Unit 1 or Unit 2 in the first quarter. The first thing you have to remember is you do have to remember the process called dimensional analysis. And this might take 2 videos, so hang in here with me. So dimensional analysis is the process by which we convert from one unit to another using conversion factors. So a conversion factor comes from an equality. So for instance, let's try that again. 1 meter is equal to 100 centimeters. So that's an equality. So I can put that into 2 conversion factors. I could say 1 meter is the same as 100 centimeters. Or I could say 100 centimeters is equal to 1 meter. I could use another equality. I could say I have 1 kilometer is equal to 0.6 miles. I can change that into 2 conversion factors. I could say 1 kilometer is the same as 0.6 miles. Or I could say 0.6 miles is the same as 1 kilometer. Okay, so I'm going to use these conversion factors to convert from one unit to another. So for instance, if I said I ran 25 kilometers last weekend, and I wanted to know how many miles that was, I would choose the correct conversion factor. I'm going to use this one because I want to get rid of kilometers and be left with miles. So I'm going to set it up like this. I'm going to say 1 kilometer is equal to 0.6 miles. Cross out kilometers. Now, if it's easier, you can put a 1 under here. And you need a calculator and periodic table for sure. So I'm going to do 25 times 0.6, because there's nothing on the bottom to divide it by, is equal to 15 miles. So before we get into reaction stoichiometry, you do have to remember how to do dimensional analysis. Okay, that's one thing you need to do. The next thing you need to remember is how to calculate and find the molar mass of an element or a compound. So this is where you need your periodic table right here. Okay, so to find the molar mass of an element, I'm going to take this average atomic mass and label it grams per mole. So if I have 1 mole of hydrogen, the mass in grams would be 1.0080. Now, when it's molar mass, we usually round it to 2 places past the decimal. So if I need the molar mass of an element, I come to the periodic table, I find the atomic weight, and I'm going to label it in grams. So if I needed 1 mole of helium, the mass of that helium would be 4.00 grams. Carbon, if I needed 1 mole of carbon, I would have to mass out 12.01 grams. Just so you know, oxygen does round to 16 because you use it a lot. So if I needed 1 mole, okay, of oxygen, I would have to mass out 16.00 grams. So again, remember, a conversion factor is made from an equality. So if I had 1 mole of carbon, its mass in grams would be 12.01 grams of carbon. This whole equality represents the molar mass. I could write it a different way. I could say the molar mass of carbon is 12.01 grams per mole. If all I did here was I just separated this, 1 mole is equal to this mass in grams. So if I wanted 1 mole of oxygen, I would have to mass out 16.00 grams of oxygen. Okay. Now again, this is the molar mass of a substance. And the only connection we have between moles and mass is the molar mass. So let's say I'm going to have to insert another document here, blank page. Here we go. So now I want to find the molar mass of a compound. So molar mass of a compound or molecule. So if I wanted to find the molar mass of H2O, I need the molar mass of hydrogen and the molar mass of oxygen. So I'm going to go back to my periodic table, and I know the molar mass of 1 mole of hydrogen is this mass, and 1 mole of oxygen is this mass. But I have 2 moles of hydrogen because I have I've got the subscript 2. So, go back here. So I have hydrogen, I have 2 of them, each with the molar mass of 1.01. I have oxygen, I have 1 of them at 6.00. So I'll multiply these together. So I get 2.02 grams of hydrogen, and I have 16 grams of oxygen. So if I add those together, okay, the molar mass of water is 18.02 grams per mole. Now, again, I can change this into an equality. I could say 1 mole of water is equal to 18.02 grams of water. So what I can do, again, is I can take this equality and I can make 2 different conversion factors. I could say 1 mole of water is equal to 18.02 grams, or I could say 18.02 grams of water is equal to 1 mole of water. So this represents the molar mass of water. This represents the molar mass of water. This represents the molar mass of water. Okay, so those are the first 2 things you have to understand. So the next thing, keep adding some pages, is you do have to remember how to balance a chemical equation. And anytime you do these stoichiometry problems, you have to balance a chemical equation. So if I have hydrogen plus oxygen produces water, I have to figure out, I have on this side of the equation, I have 2 hydrogen. This side, I have 2 hydrogen. This side of the equation, I have 2 oxygen. This side, I only have 1. So I have to put a coefficient right here. That changes the number of hydrogen. So 2 times 2 gives me 4 hydrogen. And I only have 2 here, so I'm going to have to put a 2 right here. 2 times 2 is 4. 2, I have to pretend there's a 1 right here. This 1 times 2, that tells me I have 2 oxygen and 2 oxygen. So these, I'll change my color here. These coefficients represent the number of moles of the substance needed. Now I don't have a coefficient here, but I have to pretend there's a 1. So for this reaction to happen, okay, I have to have 2 moles of hydrogen. The 2 means I've got 2 hydrogen atoms linked together. I need 1 mole of oxygen, and I need 2 moles of water. So these coefficients represent the number of moles needed, okay, for the reaction to be balanced or for the reaction to take place. Now we can find the mole ratio of one substance to the other just by looking at my coefficients. So if I need mole ratios, this is how I find it. I have a 2-to-1 ratio here. I have 2 moles of hydrogen to 1 mole of oxygen. That's 1 mole ratio. I have 2 moles of hydrogen to 2 moles of water. So 2 moles of hydrogen to 2 moles of water. Not done yet. I have 1 mole of oxygen to 2 moles of hydrogen. I have 1 mole of oxygen to 2 moles of hydrogen. I have 2 moles of water to 2 moles of hydrogen. I have 2 moles of water to 2 moles of hydrogen. I also have 1 mole of oxygen to 2 moles of water. So I'm going to squeeze it down actually in the middle. I have 1 mole of oxygen to 2 moles of water. I got another one. I have 2 moles of water to 1 mole of oxygen. 2 moles of water to 1 mole of oxygen. So from this equation, I can get 1, 2, 3, 4, 5, 6 mole ratios. The only way you can link one substance to another substance is by their mole ratios. So the only connection I have between hydrogen and oxygen is my 2-to-1 ratio. The only connection I have between my oxygen and water is my 1-to-2 or my 2-to-1 ratio. The mole ratios are going to link one substance to the other in a chemical equation. Okay, so let me explain to you the different, I'm going to just add, running out of time. I'm going to have to do this in two videos. Okay, so the next thing is we have to look to see the different types of reaction stoichiometry problems. Okay, so the different types of problems you are going to see in reaction stoichiometry. You could see a mole-to-mole ratio or a mole-to-mole problem. These are reaction stoich problems. These are the different types. You could have a mole-to-mole reaction. So you're given moles and you have to convert to moles. So you're given moles of substance A and you have to convert to moles of substance B. You might be given a mole to mass problem. So you're given moles of substance A and you have to convert to mass of substance B. You might be given a mass to mole problem. So you might be given the mass of substance A and you have to convert to moles of substance B. The last one is a mass to mass stoichiometry problem, which is the longest. So you might be given the mass, that would be in grams, of substance A, and you have to find the mass in grams of substance B. Okay. The hardest or longest ones are the mass-to-mass problems. And the only way you can connect one substance to the other is through a chemical reaction. That's why it's called reaction stoichiometry. So I'm going to stop this video right here, and I'm going to start the next one, and I'm going to help do a few problems. You need your periodic table, and you need your calculator.